We're on page 19, topic 6. The topic's called graphing linear equations, and there are three parts that we're going to look at. First of all, we're going to look at defining a graph. What does it mean? What is the definition of a graph? Then we're going to look at a special kind of equation called a linear equation, and then we're going to combine the definition of a graph with the definition of a linear equation to actually look at the graph of a linear equation. So let's start off by looking at the definition. And the definition of a graph is really a collection of rectangular coordinate points, that is XY values. We've previously discussed this under topic 5. So when we have a collection of these points, these represent all the ordered pairs that satisfy an equation or an inequality in two variables. For example, we're going to see the application of this below, where we're going to get a series of XY values that are the ordered pairs that satisfy a linear equation. So what is this linear equation? It's an equation in two variables, so we have x and y, that can be written as y equals ax plus b. A and b are simply numbers that appear on a real number line. We discussed this in topic 1, but as long as they appear on a real number line, then y equals ax plus b represents a linear equation. Now, a and y cannot both be 0, so that's one of the requirements. If they're both 0, we no longer have a linear equation. So how do we apply this? Here's a linear equation, y equals 2x plus 1. In this case, a is the coefficient of x. You can see this right here. It's the number in front of x, and the number in front of x is 2. So a is 2. And b is the last term here, so it's plus 1. So b is 1. So this is an example of a linear equation. We have two variables, x and y. And if we get a set of ordered pairs that we can plot, if we've got a set of ordered pairs and we connect them, that'll give us a linear equation. Here we see a set of ordered pairs. When x is 1, y is 3. When x is 0, y is 1. When x is minus a half, y is 0. And when x is minus 1, y is minus 1. Now we're going to show how we calculate this, where we got this from. But basically what we do is start off by choosing low number values of x here, then plugging them into this equation and calculating the y. So here's the y value. So for example, when x is 1, y is 3. When x is 0, y is 1. And we're going to, just in a few seconds, we're going to show the actual calculation, how that is done. But it's just a matter of substituting for x. We choose the x. So we choose a value for x and then calculate the y that goes along with it. So therefore we get an ordered pair. So here we see the first ordered pair, 1, 3, right here. So we have 1, 3. Here where x is 0, y is 1. So x is 0, y is 1 is that point right there. And we call that the y-intercept because it crosses the y-axis right here. This is the y-axis. So when a point crosses the y-axis, we call it the y-intercept. Another point is if we choose x is minus a half, y is 0. So when we choose x equal to minus a half and put it into this equation right here, y will equal 0. We'll do that calculation shortly. Finally, fourth order pair, when x is minus 1, y is minus 1. So here we have four ordered pairs. And when we connect these points here, draw a little arrow up here and a little arrow here, that is the graph for the linear equation y equals 2x plus 1. These represent ordered pairs, x and y values, and they fit on the equation. Just one little note here. You see this point minus a half comma 0. This is what we call the X-intercept because the graph crosses the x-axis. This is the x-axis. So this is called the X-intercept, and this is the Y-intercept because it crosses the y-axis. Let's see just how we calculated these ordered pairs. And we substitute into the equation y equals 2x plus 1. So we choose a value for x, simple values for x. Let's say when x is 1, y equals 2x plus 1. So we substitute 1 for the x. And when we add 2 plus 1, we get 3. This gives us the first ordered pair of the four that we have. So 1, 3 represents an ordered pair that behaves according to the equation y equals 2x plus 1. When we put x equal to 0, y equals 2x plus 1, but x is 0. 2 times 0 is 0, plus 1 is 1. So this is 0, 1. Now, because this crosses the y-axis right here, we call it the y-intercept. Note that when it crosses the y-axis, x is 0. So along here, if you go x is 3, x is 2, x is 1, here x is 0. Along here, at this point right here, x is 0. So this is called the y-intercept because it crosses the y-axis. Now, when we choose x equal to minus a half, y equals 2 times x, which is minus a half, plus 1. 2, the 2's cancel, and we're left with minus 1. Minus 1 plus 1 equals 0. So minus a half, comma 0 is this point right over here. That's an ordered pair that fits the equation y equals 2x plus 1. And because we're crossing the x-axis, this is the x-axis, we call this the x-intercept. Along the x-axis, y equals 0. Notice y is 1 here. Here it's 0. Y is minus 1, minus 2, minus 3. So right along this line here, along the x-axis, y equals 0. That's important to remember. Okay, so when we join these 4 points, we get the 4 ordered pairs that fit the equation y equals 2x plus 1. So just to recapitulate, the definition of a graph is a collection of rectangular coordinate points, and we saw that right over here. All these points are rectangular coordinate points that fit the equation y equals 2x plus 1. Now, we have just shown that one way of obtaining a graph is to choose values of x and then calculate the corresponding value for y using the equation. We can do this in another way, and it's called the method of intercepts. This can be a quick way to obtain a graph. Now we know that where the graph crosses the y-axis, we saw that x was equal to 0. So if we want to find the y-intercept, we set x equal to 0, and we put that into the equation. X is 0, and we get 2, 0 plus 1. So when x is 0, y is 1, and there's the ordered pair. X is 0, y is 1. So we have 1 point. Now, we can't draw a straight line with 1 point. We need at least 2 points. This is a linear equation, meaning it's the equation of a straight line. And now we need a second point. So what we're going to do is find the x-intercept, where the graph crosses the x-axis. Y equals 0, where it crosses the x-axis. So we're going to put 0 into y right here. We get 2x plus 1. We move the 1 from the right-hand side to the left side and make it minus. And then we divide this by 2 and that by 2. Let me repeat that. We already have one intercept. If we could find another point, in this case the x-intercept, we have 2 points, and therefore we could draw a straight line. And we're going to show exactly that shortly. So for the x-intercept, y equals 0, so we're going to substitute 0 here. That means we got 2x plus 1 equals 0. We got to solve for x. We bring the plus 1 from the right to the left, make it minus 1. Divide this by 2, I get x. Divide this by 2, I get minus a half. So now we know when x is minus, or when y is 0, x is minus a half. So we have one ordered pair right here, and we have another ordered pair right there. So now we can draw the graph. Remember, the y-intercept is the point at which the graph crosses or intercepts the y-axis, x equals 0. So here we see this point 0, 1, where x is 0, is the y-intercept. This is the y-axis. So where it crosses it, x equals 0, and the intercept is at y equal 1 here. Now, the second point, the x-intercept, which we just calculated, is the point at which the graph crosses the x-axis. So it's got to cross this axis at some point. At that case, y equals 0. When something crosses the x-axis or is on the x-axis, y equals 0. When we set y equal to 0, x was minus a half. So we have the point 0, 1, which we calculated, minus a half, 0, which we calculated. Let's just look up here. Here they are. 0, 1, and minus a half, comma 0. So 0, 1, and minus a half, comma 0. I put the point, shown them as a capital X, where they cross it, and then I drew a line connecting these two. And that's the straight line. Now, if you go look at the previous one, which was for the same equation, this point and this point are the 2 points in this graph. These are these 2 points right here. This point and that point right there are represented by this and this, which we showed on the previous page. So there's the y-intercept right there, and there's the x-intercept. And what we said was we can draw these 2 points. Once we draw these 2 points and we continue them, then they continue in that direction, and the point 1, 3 would fall on the line, and the point -1, -1 would fall on the line. So what we're saying here now is there are two ways that we can draw a graph. One way, as we saw before, was to find ordered pairs, and you can choose as many as you want. Probably good to do 3 or 4 to make sure that they all lie on a straight line, that you've done the calculation correctly. So this is the method where we just choose the ordered pairs, we choose values of x, and then calculate the corresponding value of y. And we got this. The other method, which is called the method of intercepts, is to set x equal to 0 and then calculate y, set y equal to 0 and then calculate x, then plot the 2 points that represent, here's the y-intercept right here, here's the x-intercept right here, connect them, and that way we have the graph. Now, here are page 20. We have 2 more examples which we'll go over on page 20, so we'll do both of these equations. Let's take a look here. Now, in this case, we're asked to use the intercepts to graph the linear equation 2x plus 3y equals 6. So we know for the y-intercept, where the graph crosses the y-axis, x is equal to 0. Any place along here that the graph crosses, x equals 0. So we set x equal to 0 in the equation. 2 times 0 means that 3y equals 6, so y equals 2. So 0, 2 is the y-intercept right here. The coordinates, the x and y coordinates of the y-intercept. For the x-intercept, along this line right here, from here to here to here to here, this line, y equals 0. So we set y equal to 0 in the equation. If we set y equal to 0, 2x equals 6 and x equals 3. So we have 3, 0 because we set y to 0. There's the x-intercept. So we have the x-intercept and we have the y-intercept. We connect the points. We should put a little arrow here, a little arrow there. And that gives us the equation of the graph. Now, you could also find another point in the line by choosing an x value and calculating the corresponding value. If you wanted to check it, you could do that. So, for example, if you chose x equal to 1 and substituted it into here, you'd have 2 times 1 because you substitute the x plus 3y equals 6. So, if you solve for 3y and you bring the 2 from the left to the right, you get -2. You will get 3y equals 4. You divide the 3y by 3, you get y. You divide the 4 by 3, you get 4/3. So the xy pair that would lie on the line would be 1, 4/3. Now let's take a look. Here's 1. You can see if you go up roughly 1 1/3 on the y scale, 4/3 is 1 1/3. 3 goes into 4 once, and there's 1 1/3. So this point here, right here, represents x equal to 1, y equal to 4/3. Now that means, the fact that we've shown that means that our calculation for the intercepts is correct. So the second example here is graph the linear equation y equals 3x. Now the problem with this specific example is that if you choose y equal to 0, then 3x equals 0 and x equals 0. And if you choose x equal to 0, y is 0. So you only have one point. Let me go over that again. If I choose y equal to 0, 3x equals 0. So x has to equal 0. And if I choose x equal to 0, y is 0. So I only have one point. I know 0, 0 lies on the line. So what am I going to do? Well, I just choose a value for x, and usually a low one. I'm not going to choose 1,000 or 500. I'm going to choose a low value. I choose an integer value that's low, and I plug it into the equation. So here I plug x equal to 1 into the equation and y equals 3. So when x is 1, y is 3. There's the second point. There's the first point. I connect the two, and I get the equation of the straight line. Now notice, if I chose x equal to 2, then y would equal 3x, which would be 3 times 2, which is 6. So when x is 2, y is 6. 2, 6 is also a point on the line. And if you look over here, 2 and 6 would be somewhere up here probably, or somewhere here. So it does make sense. You can choose other values to see. So in the case where you can only find one value, where you get x equal to 0, y equals 0, when you set y equal to 0, x equals 0, you have to choose another value. And you choose a low number value.